Well, good morning or afternoon, but you should be watching this on Wednesday. If you are at home, so that means Group B. Here are your notes for today. Feel free, if you don't want to listen to my extra commentary, you can click through the slides and read through them yourselves. But when we start out our basis for this entire school year, one of the most important things to do is to understand what matter is and how we actually classify different types of matter. So remember, matter is defined as anything that takes up space, which means it does have a volume, so it has three-dimensional shape, and it does also have mass. So anything that has mass and takes up space or has volume, okay? So remember, your mass is the amount of stuff that makes up you. Your mass, no matter whether you are here on the earth versus on the moon, you have the exact same mass. You have the exact same amount of stuff that makes up you here and there. Now, your weight when you stand on a scale would look different, but the amount of stuff that makes you you is still there. The volume, again, this is the amount of space occupied by that object. It could either be measured in liters or meters cubed. So when we look at this overarching umbrella of what is matter, so anything that you can basically see, touch, or smell is going to fall into that classification of matter. Only things that aren't matter are types of energy. So think about heat. That would not be a type of matter. All right, so with matter, it either gets classified into a pure substance or a mixture. When I look at a pure substance, I have elements, I have compounds, and then I can also add in one more grouping over here. And that final grouping would be any guesses? Dun, dun, dun. This would be a molecule. All right, so a element is when we have one single type of atoms. So this would be like oxygen gas, O2. It is only oxygen bonded to oxygen, right? Or it could be aluminum foil, Al. A compound is a combination of two or more elements that are actually chemically bonded together. So how about water? We have a hydrogen bonded to an oxygen bonded to another hydrogen, or H2O. You can always tell whether it is a compound or a element simply by looking at how many elements you have. So in my compound, I have two or more elements, two or more capital letters. Okay, a capital letter denotes the start of a new element. So you may not know what this is. Okay, so C6H12O6. Well, I see that capital letter C, capital letter H, capital letter O, so I know there's at least three different types of elements in this actual molecule. If I see Li2O, I have lithium, capital L, lowercase I, and then oxygen that are going to be bonded together, so those fall as a compound. If I see something like Zn, which would be zinc, do you see how the N is not capitalized? If it is not capitalized, then it is not a different element. That is just one element by itself. All right, so again, you have pure substances. Those pure substances are made up of just one type of matter. So it's just water, or it's just oxygen. It is not going to be a mixture. That molecule over there, we haven't quite talked about that one just yet. With a molecule, we are looking at two or more atoms that are bonded. Those two or more atoms that are bonded could either be the same, like O2. I have two atoms right there. Or something like H2O, which even though it doesn't say next to O, there's a 1 there. So it has three atoms. So they can be two the same atoms or two different. So both oxygen and water would count as a molecule. All right, so that's kind of our divide. Okay, all of those are made up of one specific type of matter. Whereas mixture is going to be made up of two or more different types of matter. So ask yourself this. Salt water. So if they're at the sea, salt water has both salt, which is NaCl, and it has water, H2O. Those two are not chemically bonded. The salt is dissolved in the water. So just because it's dissolved and suspended throughout the water does not necessarily mean that it's chemically bonded. So I would say that I have salt and I have water. Okay, so salt and water, I don't say that they are actually bonded. You see how those two formulas are separate? So when I think of the sea, the nice thing about the sea is that salt is suspended throughout, right? So there's little particles of salt all throughout that water column. It is not a layer of salt up top and then a layer of water down below. It does not look like that. Okay, so if I have a homogeneous mixture, homo, that prefix in Latin means the same. So if it is a homogeneous mixture, that means it is the same throughout. I can kind of cut this picture into thirds, and I see green molecules, orange, green, in all of the different layers. So this one does not have distinct layers. It does not have distinct parts. Whereas if I look at this one, the hetero, prefix hetero means different. So we have different layers. So we have one layer up top that has a different chemical compound than the layer down below. So if it is a heterogeneous mixture, we typically see layers. All right, so again, elements, one type of atom. This would just be denoted by one chemical symbol. Does not matter on the number of atoms. Okay. So that means S8, sulfur with 8 atoms bonded together. That is one type of element. H2, hydrogen gas, that is one type of element. Aluminum, Al, that is one type of element. Okay. Compounds, again, 2 or more different types of atoms that are chemically bonded together. So when we write this, we write it as one complete compound where the letters are actually touching each other. They're kind of smushed together. So we have LiO2, H2O. You see how they're kind of smushed together? So with our substances, again, you got elements, you got compounds, you got molecules. And then our mixtures, again, same deal. They're not chemically combined. So we would say salt and water, right? I'm not actually smushing those together. It is not NaCl H2O, right? It's not all smushed as one. That does not happen. So these can be easily separated depending upon what techniques we actually want to use. When I separate these on out, I am able to actually see the different components of that mixture. I want you to think about that mixture as kind of like trail mix. In trail mix, you know how you have large distinct parts? You got the M&Ms, you have the almonds, you have the peanuts, right? You always go for the M&Ms first, right? And so you can separate out all the M&Ms first before you eat the Chex Mix, because everybody knows that's the one that you leave to the end, right? It's also really important that with our mixtures, there's no set proportions. So when I look at water, I always have 2 hydrogens to 1 oxygen. Whereas if I look at salt water, I'm getting ready to boil water so that I can actually make my pasta for dinner. I'm just going to dump some salt in there. I'm not going to have a set proportion. I'm just going to go dump until I think that it is good. So that proportion could possibly change. All right, so a homogeneous mixture. Again, those particles are evenly mixed. That prefix homo means same. If it is heterogeneous, again, that prefix hetero means different. Your individual parts are not mixed evenly, so you would see layers. Okay, so that would be like trail mix, a thicker type of salad dressing, sand, and water. They do not mix nicely together. All right, types of mixtures. Again, homogeneous, no layers, uniform throughout, does not display the Tyndall effect. So when it does or does not display the Tyndall effect, this is an example of not displaying the Tyndall effect. Do you see how that light is able to pass straight through? Whereas here you see a little bit of scattering of those light particles. So those light particles do not pass through easily, and so that does display the Tyndall effect. So the reason why it kind of scatters that light is because we have particles that are going to be suspended throughout that are large enough to be able to interfere with the light that is passing through. So that's why we sometimes see the Tyndall effect and sometimes we don't. We wouldn't see it with homogeneous, we would see it with a heterogeneous mixture. All right, a couple terms I want you guys to know. Your solution, another name for a solution, is just a homogeneous mixture. So if I think about lemonade or Kool-Aid, right? So the solution is the entire mixture. That is the Kool-Aid. The solute, cute, that's how I always remember it. Solute, cute. Okay, those are things that are really small, like cute little puppies, cute little babies, right? The solute, cute, that is what's always going to be in the lesser quantity. That's what's smaller amount. Solvent, I think of vents in the big ceiling, and I think, okay, well, those are really big. This is what's going to be in the greater amount. Okay, so when I think of my Kool-Aid, do I use a lot of the sugar and powder combo, or do I use a lot of water? And hopefully you guys say the water goes with the solvent. So my water is going to be the one that does the dissolving, and what gets dissolved in the smaller amount is the powder, right? So I have being dissolved powder, doing the dissolving, that is my water. The overall Kool-Aid mixture, that is my solution. All right, taking a look at these couple that we have, I want you to try to identify, is this a pure substance or mixture? So in the first picture, if you look, and I compare those two different molecules, are those the exact same molecules? Hopefully you're saying no, and you can say that this is a mixture. If I look at all of these, boom, 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 do you see how that is all the exact same compound? Because it's all the exact same compound, it is a pure substance. This one, we have two white atoms, and then we have two blue atoms that are not bonded together. So since they're not bonded together, they are two different types of matter. Since there's two different types of matter, very similar to the first one, this is also a mixture. All right, again, pure substances or mixtures. Look at this one. You see how I only have the red atoms? That is a pure substance, and it is an element because we only have one type. This would be like Al, 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 aluminum, aluminum. Look at this one. We have O2, 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 O2. It is a pure substance. There's only one type of matter that is found in that picture. And because I have two things that are bonded together, this is a molecule. But since it's both oxygen bonded to oxygen, it is also an element. So it can be multiple things. All right, let's look here. That guy, that guy, that guy. They're all the same. It's the same type of molecule. So this is a pure substance. But since it is more than one different type of element that are chemically bonded, it is no longer an element. It is a compound. With that compound, it is also a molecule. Because if you look, I have 1, 2, 3, 4 atoms bonded. So they can either be 4 the same or 4 different or a combination of each. It does not matter. All right, take a look in this final picture. I see red atoms. I see 2 blue atoms bonded together. And then I see a purple bonded to 3 greens. So do you see how each of those are 3 different types of matter? So that means this must be a mixture. All right, a special type of homogeneous mixture is what is called an alloy. An alloy is actually a mixture of several types of metal. Okay, so if I look at brass, brass is actually a combination of combination of copper and zinc. Okay, so depending upon it, it's going to have different amounts of copper and zinc depending upon the actual use of it. Steel as well. We use steel for a lot of different building things. It's a lot stronger than other metals, so that's why we use steel. All right, again, heterogeneous mixtures do display the Tyndall effect. Homogeneous do not. Okay, so this one right here, if you look at this tube, you see how there's no scattering of light. The light can pass on through. Whereas with these two, you see how the light gets scattered a little bit. Okay, with the scattering of that light, you see it is collided with some of those particles. So if you have those larger particles that do not allow light to pass through, then that would be heterogeneous. And that's it for today, guys. So with our notes, what I want you to do, there's a little introductory kind of video that goes over our concept map, but you are going to be breaking down matter into the different areas that we actually classified in as pure substances and mixtures, and then keep adding some extra characteristics about those, as well as some examples. So you guys have that concept map for you to do, so you are going to do that after you finish watching this video. Okay, if you have any questions, please bring them with you on Thursday when we get back into class, and we'll be able to help you then. All right, you have a great one. Thanks, guys. Bye.